Hi kids! Today we're doing lesson 31 in Module 4. We are super close to the end of Module 4 and we have learned so much. We're going to continue with the really big important lessons. Today, lesson 31 is as big as they get. Divide decimal dividends by non-unit decimal divisors. So much like the past couple of lessons, we're really going to be thinking about what to do when we have a decimal and how to get that decimal out of the divisor, and whatever you do on the outside of the bracket, you do on the inside, because this is that ratio that we had in the fraction form earlier. So we are using a scale factor. Basically, multiplying by 10/10 is scaling it times 1. So we're not changing the value of these numbers, we're just changing the ratio so that they can, well, we're keeping the ratio the same, but we're changing the look of them so that they are still, we're going to get the same division answer, but each one is 10 times greater, so you get the same answer. So anyway, we're thinking about scale factors. The most important thing here is that we want to express the divisor as a whole number instead of a decimal fraction. So that's a big part of this lesson. And again, if you need to take the time, pause the video and write down these notes. So we have some samples here. Instead of just multiplying with or dividing with 1 and 1/10, it's kind of more fun if we can do some bigger numbers. And so another part of today's lesson is recognizing what your math facts are. If you know your math facts, you're going to have a great time today. If you don't really know your math facts, multiplication facts, then you may want to have a grid, a multiplication grid, where you have your factors on the outside and then all the products on the inside. That could really help you speed up the process. There are many of those online. Just search multiplication table. So if we have something like 34 and 8/10 divided by 6/10, we can still turn this into a decimal, multiply by 1, but 10/10 is a scale factor because we need to move this decimal out. Remember, the bottom number is in charge, okay? That used to be the number sign before it was a hashtag or whatever those super fun things are that all you young people use. So multiply by 10 to get it out of this one. Whatever you do here, you also have to do here. Turn this into a whole number. Voila, normal division. Same thing here, 7.36 divided by 8/100. This denominator is in charge of the power of 10, 100, or 1,000 that you're going to multiply by so that you can turn this into a whole number. When you see it needs to move 2 places, then multiply by 100 on the top and the bottom, get a whole number divisor. Oh, and then look at what fun. We can turn our paper and wha-bam, there's your answer. Don't ask me why I have it all on the bottoms. I don't know. Must have run out of space. Anyway, here are the last ones that are your warm-up for today. 4.55 divided by 7. Turn it into a fraction. 4 and 55/100 divided by 7. Multiply. Now, when you have 2 here and 1 here, don't panic. The bottom number is in charge. You could multiply by 100, but we figured out through trial and error, okay, that the best one is to just move the decimal 1 place. So here's why. I can still divide 45.5 by 7, okay, and I will end up with 6.5. What happens if you have bigger numbers? Because sometimes people will say, well, I'll multiply it by 100 hundredths. Yes, because this one has 2, because I forgot which one's in charge. That's okay. You will survive. If you change it and multiply by 100 hundredths, you just get bigger numbers. So you have harder work ahead of you. And if that's what you want to do, you go right ahead and make it hard for yourself. I don't want it to be difficult. I want it to be easy. So I'm trying to make it easy. But here we have the same problem, but what happens is it's 10 times greater than this one. And so you have 455 instead of 45.5. We end up having to annex a 0 anyway, because after you multiply 6 times 70 and get 420, you have 35 left. You got to annex the 0, bring it down, and do more division. So why go through all this hassle when you could just do this? Look, less work. Look, more work. Blech. That's a hassle. I could even multiply it by 1,000 thousandths, and I would have the same answer. So this is what we're trying to avoid, is making numbers really big and making things difficult. And if you want a mini grammar lesson, this one is super funny. The koala eats, shoots, and leaves. Hooray for the koala. The man eats, then he shoots, and leaves. Ah! So anyway, we're going to learn to cut and paste, kids. Or are we going to learn to cut and paste, kids? No! Oh my gosh, commas can save lives. That is your grammar lesson for the day. Okay, that's a fun one. Let's get into the book. So lesson 31, problem set. Here we go. Use those commas when it's direct address. Okay, estimate and then divide. Oh, another part of today's lesson is to do a little bit of pre-thinking before we actually do the division. Why? So that we can check and see, are we close? The thing here is going to be, look, it's 3 digits before the decimal. Look, it's 3 digits, okay? 112 is a whole number, 110 is a whole number. There are no decimals. What you might end up with, and we'll keep checking, hopefully I won't forget as we go through, is to make sure you don't end up with like 11.2, because that is nowhere near 110. So when we start dividing with decimals, it is important to check your work. Okay, here's what we're going to do. We're going to take these decimal problems. We're going to turn them into a fraction like we did in lesson 30. We're going to multiply by this scale factor of 10 like we previously did to move the decimal out of the divisor, turn this into a whole number. Then we do the standard algorithm, which we've done before, so hopefully I'll be able to go through that pretty quickly. And then you get your answer, and you can write it here. It's kind of redundant. I sometimes won't even write this. I just circle it up here and then do a quick comparison between your estimated answer and your final answer. So let's get to it. Hopefully I won't have any interruptions like yesterday. Oh my gosh, the previous lesson, crazy. Hey, focus. Okay, it will focus. It will. I will make it focus. Okay, 53.2 divided by 0.4. First, we have to do the approximate and the rounding. So this is where the fact families and the multiplication sheet are really helpful, because what we're trying to do is find something that is a multiple of 4. And some kids will say, well, 40 is pretty close to 4, and I know that that's 4 times 10 is 40, but I'm saying, you know, it can go a little bit higher. So what would be higher? That could be near 50. If you're not sure and you want to start at 40 for the 10, then it would be 44 for 11, and then 48 for 12, and then just go one more and you get to 52, and that's 13. And so, but this is going to be, of course, with decimals. So think about that as we go through this process. 532, 53.2, sorry, lagging here, divided by 0.4. And then we're going to multiply by 10 tenths, and we're going to turn that into 532 divided by 4. I think I skipped a step or so, but that's all right. We'll get there. And we'll do 4 into 532. Okay, so now we're going to start doing our standard algorithm. And we've got our 5 divided by 4 is 1. 1 times 4 is 4. Do the subtraction, get 1. Always do a quick little check. This has to be less. We want the remainder to be less. Then we bring down the next one and continue dividing and do the whole thing again, the division family. Divide, multiply, subtract, compare, bring down, dad, mom, sister, cousin, brother. That's the division family in that order over and over again. So we're at the divide again. 13 divided by 4 is 3, because 3 times 4 is 12. Subtract, get 1. Quick compare, bring down the 2. We get the 3. 3 times 4 is 12. We subtract. I always like to put a happy face because I'm happy when I have no remainder, because I just don't have to think about it. So, so let's see. So if we do our estimated, back to our estimated, let's say this is about 520 or 52. Yeah. Divided by 4 tenths. And so that's where we're going to end up with our approximately If I move that, then that's where I get the 133 or 130. So yes, I'm close to my actual answer, and my exact answer is 133. So this isn't the goal here. That's just to kind of check and make sure that I'm close. So this one is the next one. So if we're going to do approximate, so this would be like 16. I want to get close to a multiple of 8. Okay, divided by, haven't changed that, so that would be 8/10. And again, that's going to give me about 2. So let's set this up. I actually don't really like doing the estimated with decimals because that even confuses me. 1.52 divided by 0.8. Now, the divisor is in control. The bottom number is the one that's going to tell you how many, what multiple of 10, okay? So this one only needs one shift. Now, I could put 100, but again, it's just going to make my numbers bigger. So why not just change it to 15.2 divided by 8, okay? Because that's the most efficient way. 8 is your divisor, 15.2 is the dividend. Now, if there's no decimal here, you just put that decimal right up on top and do that first before you get started so you don't forget about it. 15 divided by 8, I can't quite get to, so it's going to have a big fat remainder of 7. But then 72/10 divided by 8, there's my 1.9, which is super close to 2. 9 times 8 is 72, and I have 0 left over. So my actual answer, which apparently I'm supposed to put down here, is 1.9. Okay? Hopefully that makes sense for you. And so just kind of comparing, am I close? Estimate and then divide. The first one has been done for you. And again, this is just kind of removing the decimal. Okay, so remove it so that you can have a clearer estimated answer. Okay, and then do the multiplying by whatever power you need to, or whatever multiple of 10 to move it out. Remember, the bottom number is in charge. And then get your problem set up for the standard algorithm, and then proceed. Okay, do a quick check just to make sure you're close to your estimated answer. So if I was to yank out the decimal, then it would be about 942 divided by 3. Okay, just 2 to the right, 2 to the right, because in my mind I multiplied by 100. Now let's actually do the work. 9.42 divided by 0.03. Now I'm going to multiply by the number that will take this out, take the decimal out of the divisor, which is also the denominator here in this fraction. And that gives us 942 divided by 3, because I moved it 2 places here, and then I moved it 2 places here. So set up your standard algorithm, and then start dividing. 9 divided by 3 is 3, exactly. Nothing left over. Bring down the 4. Divide, multiply, subtract, compare, quick, and bring down. 12 divided by 3, divide for 4, multiply, subtract, hooray! Oops, that's a crazy looking face. Anyway, the final answer, oops, which I never got C. I don't really do very good with these, but the final answer is 314. And if I was going to look at this as my estimated work here, 9 divided by 3 is going to be 3, 4 divided by 3 is going to be about 1, and then that would give me the 12, and it would be roughly 314. It's actually a pretty close estimate for an estimate. Does that make sense? It's a close estimate for just an estimate. Alrighty, next one. Some kids will do this. They'll say 96/100ths is awfully close to 1. And I would say that's fine here. And then I would just probably change that to be about 40 divided by 1 for about 40. And so I'm kind of looking for something that is just close, just something to give me a quick check. Anyway, let's move on. 39.36 divided by 0.96, because we need the actual division. Multiply by 100 hundredths, so I can move the decimal 2 times. That will give me 3936 over 96. And now we have a fun 3936. So one of the other parts to this lesson is kind of thinking about, remember the thought bubbles before? And it was like, what number do I wish I had? Well, basically, it's like you wish you had 100. And if I had 100, then I would divide about 400 by 96. But since I can't do double digits, all I can do is try for something that's, larger. So if I have my first 2 digits, okay, and then I'm looking at 96, and since I can't do double digits, I'm going to be thinking about, how about 90? So 90 times what gets me close to 40? So if I had 9 times 5 is 45, 9 times 4 is 36. So I'm thinking it's going to be somewhere around a 3 or 4, but where do I put it? Well, I don't put it here because 96 is actually bigger than 39. So I have to go over one more digit. I'm going to try a 3 or a 4. Because I had to either over or underestimate, I'm going to try a 4. 6 times 4 is 24. So let's see how close we are. 4 times 9 is 36, 37, 38. I'm actually quite close. So when you do your subtraction, you can borrow, or you can just look at the difference between 84 and 93, which is 9. Or you can do the standard algorithm and get that and end up with 9 anyway. And then 9, compare that to 96, and of course it's less. And then we bring down the 96, and well, bam, we get 196. And so my final answer is 41 for the exact, and that's pretty close to 40. So I did a good job with my estimating. Remember, it's really hard to use 100, even though you think, well, it must be close to 4 for that. But you want to also look at the first 2 digits to see if you can get a multiple that's close to that first one, and think about your multiples. 9 times 3, 27, that's too low. 9 times 4, 36. 9 times 5, 45. So anyway, I think I misspoke earlier. Probably trying to say too much. Okay. Next page. Solve using the standard algorithm. Love the standard algorithm. Use the thought bubble to show your thinking as you rename the divisor as a whole number. Okay, and don't worry about this. This is actually just, we're not always going to have to show the times 10 tenths or times 100 hundredths. So they're saying, think it, don't show it. That's all. So here they've taken the 46.2 divided by 0.3. They think times 10 tenths without showing it, because eventually that's what you're going to do in these. You're going to just rewrite it with no decimals, okay? And so we don't always have all that work that's in the background. So we end up with 462 divided by 3. Now, they already gave you the answer, so we know what it's going to be like up here. We just need to fill in the rest. So 4 divided by 3 is 1. 1 times 3 is 3. Subtract. Okay, quick compare. It's good. Bring down. 16 divided by 3 is 5. 5 times 3 is 15. Subtract. It's 1. That means we can move on. 12 divided by 3 is 4. So they give us a really easy problem. Simple. And we have a nice 0 out. So 154 is our final answer. Now that's nice that they did it all for us, but you'll see it's really not that bad as we proceed. 3.16 divided by 0.04. Now here's what I'm looking at, and I'm thinking times 100 times 100, which gives me, just go ahead and write it, 316 divided by 4. Now don't put the answer because you don't know it yet. 4 into 316. Now here we have 31 divided by 4. Well, 8 times 4 is 32. That's too high, so it's 7. 28, and the difference is 3. This is less, so I can bring down. 36 divided by 4 is 9. 9 times 4 is 36. Final answer, 79. Final answer, 79. See? It's so quick. I know you guys can do this. Just blaze on through. 2.31 divided by 0.3. Here we have 2, and here we have 1. Which one's in charge? Oh my gosh, I totally forgot. No, you didn't. It's the bottom number that's in charge. So what I want to do is I want to move it 1, and when I say it, I mean the decimal. Move the decimal once to the right. 23.1 divided by 3. All we need to do is make the divisor a whole number. 3 into 23.1, because we can divide with decimals in the dividend. Yes, you can. Just put it right up. There you go. Done. 7 times 3 is 21, and that's what knowing your facts will help you with. You won't make any mistakes in there. Subtract and get 2. That's less than 3. Bring down, and look, we got another one. So 7 times 3 is 21 for nothing left over. Hooray. 7.7. Final answer. See, it's really totally doable. You guys are going to ace these. Same thing here, 15.6 over 0.24. And the denominator is in charge. The bottom number tells you. So what happens here? It means that I have to go 2 places. Now, that'll give me 24, but what will it give me on top? 156 would be one place, so it's 156, 0. And when I say 0, I mean 0. Okay? So let's set this up. 24, 1,560. I always like to make it a little bit curvy here so nobody mistakes that for a 1. So 24 will not fit into 1, nor will it fit into 15. So we have to go all the way over here for our first partial product or first partial number in the quotient. And if you think about quarters and think of this as being $1.50, that 4 quarters are in $1, and then 2 more would make 6. And I'm pretty close to that. 6 times 4 is 24. 6 times 2 is 12, plus 2 is 14. And then subtract. 6 minus 4 is 2, and 5 minus 4 is 1. And 12 is less than 24, so we can go on. Now, I know that this is less than a quarter, so when I think about having 5 of them, because 4 would be $1, but then 5 would be $1.25. So I'm really close, but I have a little bit less. So 5 times 4 is 20. 5 times 2 is 10, plus 2 is 12. And I have exactly the right answer at 65. No decimals in there whatsoever. Okay, let's get these word problems done, and then we'll be all finished. The total distance of a race is 18 9/10 kilometers. If volunteers set up a water station every 7/10 of a kilometer, and the total distance is this, including the one at the finish line, but of course you don't need one at the start, how many stations will they have? So we're going to take our 18 9/10, which is the total distance, and divide it into sections every 7/10 of a kilometer apart. So we just take this and turn it into a fraction like we did before. And now that it's in this format, you can recognize, well, I only need to move that one time. So this really is equal to 189 over 7, which is really a standard algorithm, 189 over 7. And then this is divisible twice for 14 with 4 left over. And thankfully, look, they gave us a really easy 7 times 7 is 49 exactly problem. Yay. It's like a cyclops there. So 27, how many water stations? 27 water stations. Okay, what if they don't do every 7/10, they just have it every 9/10? Same 18.9, but different divisor. So take your 18.9 over 9/10 and then change that. Multiply by 10/10 and get 189 over 9. And the standard algorithm, I'm going to try to write a little smaller. This is even easier. 9 goes into 18 2 times, for 0 left over, and then bring down the 9, and that's a 1, and again 0. Hooray. So 21 stations with them farther apart. That makes sense. Now this last problem involves a few steps. In a laboratory, a technician combines a salt solution contained in 27 test tubes. Each of the 27 tubes contains 6/100ths of a liter of solution. Now, let's say he divides the total amount into test tubes that hold 3/10 liter. He's changing the size of the test tube. How many test tubes will he need in the larger size? This is a larger size with 0.3 because 3 is closer to 1. This is a very tiny test tube. So first of all, if I have 27 test tubes and they have 6/100ths of a liter of solution in them, I have a multiplication problem that is set up here. So what you can do, one of the ways that you can do it is to do 27 times 6/100ths. Why am I writing in uniform? Because there are a lot of zeros that I don't want to deal with. I just want to put the decimal in when I'm done. So 7 times 6 is 42, and then I have 6 times 2 is 12, plus 4 is 16. But what is ones times hundredths? It's hundredths. So it's 1.62 in all. Okay, now that's the amount of solution, okay? But we need to divide this amount into test tubes that hold 3/10 of a liter each. So we're going to take our 1.62 and we're going to divide it by 0.3, which turn that into a fraction. This is in charge, so multiply it by only 10. So that's going to equal 16.2 divided by 3, and then you get your standard algorithm. Put the decimal up, start dividing. 5, get 15, 1 left, bring down the 12. That's really 12/10. You multiply, subtract, and we have nothing. So what do I do with 5.4 test tubes? What are you going to do, break off the top of it? No. So how do you deal with 5.4 test tubes? You round up. 6 test tubes. Yay. Become a subscriber and find out all kinds of interesting things just like we did today. Hooray! And I'll see you on the next one.